My guest today is Grigore. Grigore is the founder and CEO of Pi Squared, which is an advanced verifiable settlement layer for AI and crypto. Hey, welcome to the show.
Thank you for having me, Andy.
It is a pleasure. Let's do what we do at the beginning of the show. It would be super cool if you could please introduce yourself. Would love to hear some of your personal and professional backstory. What have you been doing in the lead up to founding Pi Squared?
I came to the United States in '96 to do my PhD at University of California, San Diego. I'm originally from Romania. And in 2000, I graduated from UCSD and I worked as a research scientist at NASA in California, NASA Ames, where I learned that verifying programs, proving programs correct is hard. Then in 2002, I moved to University of Illinois at Urbana-Champaign as a professor, where I've been ever since. In 2010, I founded my first company, Runtime Verification. And then in 2024, I founded Pi Squared, which is the company I'm currently the CEO and founder of.
Yes, indeed. It's an illustrious background. NASA engineer. I think you're an early contributor to the Ethereum Foundation. All right. So Pi Squared, 2023, did you say? Yeah. Give us what's the kind of high level vision of what you're trying to do, with Pi Squared?
At a very high level, what we try to do is to bring all programming languages to Web3. And not only bring them, but bring them in the best possible way, which means correctly and universally. So correctly means that every computation done with any programming language, in the Web3 space, to be correct according to the mathematical rigorous definition of the programming language in question, and universally, meaning to work with all programming languages and with all virtual machines. And when I talk about correctness, usually what I mean and what we mean is a academic field, and not only, we mean proofs, mathematical proofs why the executions are correct. And Pi Squared, the name of our company, comes from proof of proof, because we generate cryptographic proof of integrity for mathematical proofs that justify rigorously the correctness of program executions. So it is the ultimate correctness that we can bring to computing, and we do it universally with all programming languages using the same mathematical machinery.
Yeah, so the idea, it's like if Pi Squared works, it's like the missing trust layer for a truly modular or interoperable Web3. So, for example, one of the ideas that I think you guys are talking about is the idea as to do we really need L2s, layer 2s anymore? Because you guys talk about the verifiable settlement layer as an ideal foundation for layer 2 and layer 3 rollups. But yeah, kind of the idea being to remove a lot of the cross-chain complexity. So is that one way of saying it, Grigore?
Yes, a very good way of saying it. In fact, we believe that one of the main reasons why we even have layer 2s is because layer 1s are not good enough. Layer 1s are not fast enough. They are expensive. They do not scale. And one of the reasons they do not scale is because they enforce or they implement a certain principle and protocol in distributed systems called strong consistency, which is known to be very hard to implement correctly unless all nodes have to communicate with each other. There is a very intensive, heavy communication between nodes to achieve consensus. And that's very expensive. No matter what you do, that is expensive. So that's what happens in layer 1s. Then layer 2s take advantage of this infrastructure and they make everything a lot faster. But ultimately, both layer 1s and layer 2s and layer 3s, they execute programs in some programming languages. And if we had some way to ensure that these program executions were correct, using a lighter weight protocol for consensus, actually these protocols are called weak consensus protocols, then we wouldn't need all this layered infrastructure of blockchains. So that's what we are proposing with the verifiable settlement layer. It's a universal settlement layer for computations in any programming languages, and each computational claim is settled completely independently and in parallel with all the other computational claims. And now layer 1s, layer 2s, layer 3s, and not even blockchains, but any applications, even games, they can settle their computations in this infrastructure without having to pay the high cost of sequential or strong consistency, essentially without even having to be a blockchain.
Yeah, so the pi squared verifiable settlement layer, you call it the VSL, right?
Yes.
So yeah, potentially, like we're talking orders of magnitude faster than, your typical ZKVM, right?
Yes. So there are two different steps in our approach. One is to reduce computation to mathematical proofs, and the other one is to check the mathematical proofs using a zero-knowledge circuit, so you get a ZK proof. So this allows us to get ZKVMs customized for each programming language or computing environment, as opposed to having one ZKVM for one particular language, let's say RISC-V, and then compile everything, translate everything to RISC-V. And the problem with translations is not only errors, but also that the computational integrity, computational granularity is much higher, right? So one step, let's say in Python or in Rust, translates into more than 100 steps in RISC-V. And now we have to prove all those 100 steps in RISC-V. So by generating a ZKVM directly for your programming language saves at least 2 orders of magnitude in number of computational steps that you have to then verify with a ZK circuit. All right, so that's how you save, in performance compared to traditional ZKVMs.
Yep, and it's the same with bridges, right? So the idea is that you can, make bridges kind of redundant because it's a different way of bridging, right, across chains.
Exactly. If different chains, all of them settle their computations on the same layer, this verifiable settlement layer, then essentially every chain can see what happens on every other chain in the same universal layer, and then they do not need to communicate with each other through bridges or intermediaries, because in some sense you can think of the VSL as the universal omnipresent layer that everybody integrates with, and then this provides bridging as a particular application.
What about AI agents? So how do AI agents fit into, I guess, the pi squared framework and this kind of, future interoperable Web3? So just, paint a bit of a picture of, any way you want, Grigore, but love to understand how you think about the future of Web3 where, pi squared is kind of running things and, AI agents live on chain.
So AI agents are also programs in different programming languages, some of them in Python, others in Rust. And blockchains, many blockchains have very particular programming languages like Solidity or the Ethereum virtual machines. Some of them are more related to modern programming languages like Rust or Wasm. But essentially, AI agents as programs, they need to settle their computations somewhere, and they need to pay each other. There is a certain payment network between AI agents and humans and AI agents, between AI agents themselves. And all these currently, they settle on blockchains, paying the high cost of total order sequentiality that I mentioned before on blockchains. We did an analysis of the transactions on Ethereum and on several other blockchains. We have found that more than 90% of the transactions on blockchains these days do not strictly require a blockchain. For example, payment systems. If you want to pay, if you have a network of payments, there are recent results showing that you do not need a blockchain. You do not need a total order, a chain, essentially, for payments. You can do payments a lot faster, but basically uncapped, theoretically uncapped TPS, transactions per second. You can do very many transactions per second payments. Also, settlements of states in an account. You have an account on Ethereum and you want to settle something, to store something in your account. This doesn't need a blockchain. It's an independent operation, doesn't depend on the other operations on the blockchain. And this is precisely what agents do. Agents communicate with each other. They send payments to each other. There are certain causal dependencies between different agents, but most of the time, all they need to do is to pay each other, send messages to each other, and settle, store their states. And for all these operations, what they need is a settlement layer, which needs to be verifiable, because I want to verify what an agent does for me, or agents want to verify each other. We want verifiability, and we want settlement, and we want payments. And for all these, the VSL is the perfect infrastructure. It's fast, cheap, and universal, of course, with all programming languages, and at the same time verifiable.
Yep. And we should understand, what phase are you at in terms of building out the VSL? We're in DevNet at the moment, so just kind of give us an idea as to where you are on that roadmap, or the journey to mainnet, or any way you want to kind of describe that rollout, Grigore.
Yes, so we actually just launched our mainnet yesterday, June 24th. No, not mainnet, sorry, DevNet, the DevNet.
Yeah.
Yeah, yesterday, June 24th. And the plan is to launch our testnet by the end of this year. So hopefully November, but definitely before the end of the 25. And the testnet will be already fully functional, except that it will not be yet a mainnet. It will not be, we want to test it for a few more months. So we expect the mainnet to be launched somewhere in May or June 26. So less than a year from now.
Yep. And there are validators on the VSL as well. What role do validators to play in the system?
So the validators validate all the claims that are being settled on the VSL. Each claim comes with a proof, and the proof is verified. And then there is a proof of the verified proof. That's why it's called pi squared. And the validators validate the cryptographic proof of any other proof that the claim has. So essentially, the validators shake hands that the various claims that are being settled are indeed correct. And anybody can be a validator. Any participant in the network can be a validator. The proof of proof, the cryptographic proof of the mathematical proof, it is so easy to validate and to check computationally that we can even do it with our phones.
Fascinating. And I can see that you have a number of I guess partners and backers who are helping you build out this ecosystem. I mean, in terms of the global investors, everyone from the Tezos Foundation to Polychain, Borderless, a number of others. And so there's obviously a good groundswell of support that are providing some of the funding to help you build out the Pi Squared mainnet eventually.
Yes, exactly. So we had our investment round 1 year and a few months ago in early 24. And we have a series of prominent investors and angels, and we're all aligned on the vision that we need the universal verifiable settlement layer and the super fast payment system to power the future of Web3.
And it's a funny time for Web3, Grigore, in terms of, it feels like it's a little bit difficult sometimes just to get, I guess, the next wave of users, whether they're going to be coming in and, building on some of the different chains, playing around with DeFi or whatever the various Web3 use cases are. Do you see that changing anytime soon? What do you think has to happen for Web3 to kind of, start to make that the next steps to something, mainstream or cross the chasm, or however you want to frame it?
So there are different perspectives from different angles, from different players. Users obviously need a very familiar and easy to use interface, a user interface, UI, UX, user experience is very important. And honestly, currently the user experience on Web3 is not as great as it can be, not as good as Web2, for example. Then from a developer's angle, I personally believe that we must bring all programming languages to Web3. As a developer, you grow up in school learning very, very good programming languages like Java, for example, or Rust. And then you want to become a Web3 developer and you have to learn programming languages like Solidity or EVM, which are not that great. So we firmly believe that we should simply allow all programming languages in Web3, same like we have all programming languages in Web2, right? When you buy a computer, you go and buy a computer, and then you can install any programming languages you want on that computer. It's not like you go and buy a Java computer or a Python computer. That would be ridiculous. But unfortunately, that's how the world computer, the blockchain, is these days. It is hardwired with one programming language or virtual machine, which is not even that great. And then everybody who wants to develop on that blockchain must learn that one language. So that used to be the case like 50 years ago in computer science. So now the programmers are more, I think, demanding these days. They want high-level, powerful programming languages, and we should give them all those programming languages.
Yeah, so it's really about empowering the vast global army of Web2 and Web3 developers, and just making it easy for them to build the products that they want in an on-chain universe. It sounds like a simple solution to quite a hard problem, Grigore.
Yes, it sounds simple. And actually, interestingly, it is not that difficult if you do it right. So my research area is programming languages and formal methods and formal semantics. And this is probably one of the oldest fields in computer science. It started in late 60s. And the formal semantics field, the thesis of this field is that computation in any programming language is actually mathematical deduction, mathematical proof. And if you reduce computation to mathematical proof through formal semantics, then you have a universal language to talk about computation and correctness of computation. And this is precisely what we do. So that's why we can bring all programming languages together, because we don't have to do anything specific to any particular programming language, because each programming language is a mathematical theory in this mathematical framework of formal semantics of programming languages. And by being able to generate proofs from computations and then cryptographic proofs from the mathematical proofs, now we can bring all programming languages together and interoperability. And this is the right way to do things when you want verifiability and proofs. And that's what we embarked ourselves to do.
And pi squared, Grigore, what's the thinking behind the name? What's the origin story of the name pi squared?
So, as I told you, I had a different company, I founded another company back in 2010, before blockchain was even a thing, called Runtime Verification. And what we did there was the first half, let's say the first pi in pi squared, which is to reduce computation to mathematical proof, and then to reason about programs using formal verification and generating mathematical proofs why programs are correct. And then Pi squared, the company and the name, came from the realization that we are very close now to having zero knowledge proofs, cryptographic proofs of correctness of anything that has a mathematical proof, not only computations in programming languages, but anything. And by adding this additional layer, which is very small actually, of cryptography on top of mathematics, okay, we now can achieve cryptographic attestation of correctness of computations. This is not how ZKVMs work actually these days. ZKVMs, they are circuits, cryptographic circuits, very specialized, very customized for one particular VM. That's why they are called ZKVMs. You have ZKVM for EVM or ZKVM for RISC-V, very particular VM language. In our case, we have a ZK circuit for mathematics. If we consider mathematics a virtual machine, a VM, then could be seen as a ZKVM as well, but mathematics is more than a VM. Mathematics is more general, more universal. So we have a ZK circuit for mathematics, and now we reduce any programming language to mathematics, any computations in any programming languages to mathematical proofs. And because of that, now we have zero knowledge proofs of mathematical proofs. So proof of proof, pi squared.
Thank you for explaining that very in a very articulate and elegant way, Grigore. All right. Well, look, as we finish up this part of the podcast, just for people listening that are perhaps unfamiliar with what you and the team are building at Pi Squared and perhaps intrigued to get involved or certainly keep up to date, what is the best way for people to learn more and dive into what you guys are doing, Grigore?
Well, so go to our website, pi2.network, and follow the links. Go to the DevNet, get yourself involved, join our Discord channel. All the links should be there on the website, and become a developer. Try your craziest thing on our network using your favorite programming language.
Awesome. Links are in the show notes, folks. But Grigore, that means it is time to finish up the episode. And we do that, of course, by running you through the very famous Crypto Conversation hot take round. Are you up for it?
Sorry, what is that? I don't know. Please.
Just say yes, Grigore. I'm just going to run you through what we call the very famous Crypto Conversation hot take round, in which I'm just going to ask you some kind of rapid fire hot take style questions, Grigore. It's just a bit of fun, but let's see what you have to say. Question 1 for you is, where would you say that you sit on the Bitcoin maximalist to multi-chain opportunist spectrum?
Oh, I'm definitely not a Bitcoin maximalist. I believe that blockchain should not be reserved for one particular task or one particular payment system. It should be the universal way to do computing, in which you should have all programming languages, all agents and humans, everybody interacting and communicating with each other. I think it is the future of computing.
Makes perfect sense to me. All right. Well, what would you say then is your firmest conviction crypto opinion, Grigore?
That crypto should not be only about money, that crypto is the foundation of Web3, and Web3 is about freedom to own our own assets and to have nobody between us and our assets. And the assets are digital, and they will be digital from here on. And we need the highest assurance methods to protect our assets and to transfer our assets completely under our control.
Yes, indeed. Very well said. All right. Well, Grigore, Bill Gates famously said that we tend to overestimate what we can accomplish in 2 years and underestimate what we can accomplish in 10. So with that in mind, 10 years is a very long time. Anything you like here, Web3, pi squared, what does it look like in 10 years' time?
In 10 years, I hope that blockchain and Web3 and crypto in general will not even be visible. It will be so integrated in everything we do with machines that it will be the way of being, same like internet is these days. We don't think of internet now when we talk to each other. We just talk to each other, mind to mind. All the technology is behind. We don't see it. That's how Web3 and cryptography and blockchain and all these complicated mathematics and proof of proof, that's how they should be. They should become completely invisible. We should just do our things, we and the AI and the agents, because they are here to stay. We should all communicate and get things done together without worrying about the technology underneath, without seeing all these silly little things like it's 128 bits or 256 bits, or is this hash or that hash or this Merkle tree root, or all this should disappear. And even the concept of proof itself should be so ingrained in everything we do that we should not even accept anything which is not verifiably true. And it can be done completely automatically with everything we've done as humans, as a species in 5,000 plus years of intellectual, maybe more growth. We learned how to associate proofs with everything that we want to trust. And that's how trust should be, through proofs and verifiable.
100%. 100%. Very well said. All right. Well, another way of thinking about this, Grigore, of course, is a quote I'm sure you're familiar with by William Gibson, who famously said that the future is already here. It's just not evenly distributed. So with that in mind, can you think of an example of the future being here right now, but most people aren't aware of it?
Well, I think Web3 itself, it's already here. Once you take the pill, you cannot go back. And many people don't realize that. Many people think that their assets are still in banks and in intermediaries, and they depend on this or that. But the reality is that some of us, crypto folks, Web3 folks, firm believers, already see it. That we, through cryptography and this very simple game between private and public keys, actually we own our future. I think this future is already here. It's just a matter of the masses understanding it.
Yes, indeed. Very well said again. And it brings us nicely to our final question, Grigore, which is, what is your favorite science fiction book, film, or TV show?
Oh, um, um, yeah, I don't know if I have a favorite one. I haven't thought about that. I like all of them equally when I watch them. They are just fun. I don't think of a favorite. Sorry about that.
That is absolutely okay by me, Grigore. All right. Well, in that case, I reckon it's time to close out the episode. And I would love it if you could do that by again, just once again, telling people where is the best place to go to learn what is happening with Pi Squared 2. And if you've got, Twitter X profiles, anything like that you want to share, please go for gold.
Yes, so pi2.network, and follow the links from there to link to our Discord, to our X, Twitter, and also you can find me. Just search for my name, Grigore Roșu, and you can also go to my university webpage. I'm also a professor at the University of Illinois, Urbana-Champaign of computer science, and you can see my research, our research, and all the links are on our website, Python.network.
Awesome. Thank you so much, Grigore. All the best, and bye for now.
Thank you, Andy.